All right, folks. So I'm getting kind of tired here. I'm on my last video of the nervous system here. We've done the actual system and neurons, just very basic, very, very basic. Which I wanted to mention also with the neurons, the glial cells, those are all the cushioning cells that are around, like the myelin sheath and stuff like that, that actually help neurons fire a little bit faster. Resting potential we did. Remember, that's the sodium potassium pump is the real hero there. He's keeping that salty banana. And I always want you to think resting is keeping the salty banana. Action potential is when the switch, okay, the switch, that's the actual nerve impulse. Now we're going to talk about when that nerve impulse reaches the end of the presynaptic nerve and has to jump to the next nerve, jump across that synapse. How is that message going to transmit? And we have this lovely diagram that's going to hopefully explain that. Now, on the back of this is a worksheet that has yet another diagram of the synapse, okay, and a few questions. So after you go through this, read a little bit more to reinforce it and answer a few questions to see if you really got it, okay? So now, here we are at the synapse. What's going on? Okay, we'll get to this over here first, but I want to talk about, this is our our pre-nerve here. This is our post-nerve over here. Okay, this is like kind of the end of the post, or the beginning, I should say, of the post-nerve. Okay, this is the pre-nerve. Now, what's going to happen here? Well, the signal, remember that action potential is kind of it's coming along here, right? When it gets down near the end, that's when a whole nother ion comes into play. And it's calcium. Yeah, that secondary molecule. And so calcium, being a secondary molecule, is involved in this signal transmission here. But what happens is when the nerve impulse comes to the end here, it triggers these now calcium gated channels that are closed. Okay, it triggers them to open up, and calcium starts flooding in. Okay, so here's the calcium on the outside of the nerves, and when the impulse comes on down, now this calcium gated channel, holy cow, there are a lot of channels in these nerves, right? Calcium gated channel opens up and calcium floods in. What does that cause? Well, at the end of that axon are all these little vesicles that have neurotransmitters inside them. See those little droplets? They're the neurotransmitters. Neurotransmitter is going to transmit a neuron or a neuron signal. Okay, how does it happen? When the calcium comes in, it causes all these little vesicles to kind of go down the bottom, pop, 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 pop. Okay, and they kind of explode by good old exocytosis, right? Exocytosis going on here. So the little vesicles carrying the neurotransmitters, because the calcium rushes in, it pushes them down here and literally makes them pop into the synapse. Now, those neurotransmitters got to fit like a key into a lock, and that's what this is here. This is the neurotransmitter. This is the neurotransmitter. Write that out there, the neurotransmitter, and it's fitting in. This is one of those ion channels. Remember, that's what type of receptor we have here. So the neurotransmitter, which is called a ligand now because it's a substance that happens to be made out of protein, attaches to the receptor. Okay, and if it attaches like a key to a lock, this is the receptor over here. I don't need to write that down. You're listening to me. Maybe you're writing it down. You should. And once that does, it opens up. Okay, what is this doodad here? It's kind of letting sodium flow in. It's letting potassium flow out. Kind of looks like the reverse of a sodium-potassium pump. It's just a ligand-gated ion channel. It's just another ion channel in the many, many players in your neurons, okay, that's going to allow that. If the neurotransmitter attaches, the gate opens up, and sodium and potassium do the old switcheroo. Okay, sodium starts rushing in. That causes that depolarization. If it reaches the threshold, then all the sodium-gated channels now that are all along the next neuron are all going to open up, and we're going to have the rising, then we're going to have the falling, the overshoot or the undershoot, and then back to normal, okay? And here's where once those neurons, if they're attached, things are flooding in and out, and it helps it to reach that threshold to let it all go loose, right? Excuse me. Once it all goes loose and that nerve impulse goes along, then those neurotransmitters need to unattach. And they will. They'll unattach. These little gates will close up, and the nerve impulse travels on to the next one and the next one, and so forth and so on. So in the synapse, we have another player here, the calcium ions. We have exocytosis of the neurotransmitters. We have a signal attaching to its receptor, its ion channel receptor, like a key to a lock, that causes that ion channel to open up. And if enough sodium flows out sodium flows in and potassium flows out, then we reach the threshold and the next nerve fires, okay? Next nerve fires. So that's what happens at the synapse, and that's the end of all our nerve talk here. Hopefully that helps, and that's it for nerves.